This class is an analytical physics 3. It's the third in the sequence, and we talk about relativity and also waves and oscillations. And waves and oscillations are all around us. Every interaction we do, from the sound waves I'm talking about right now, the light that's bouncing off me, are waves. And so get to know this, we're really familiar with those kind of things, but talking about it in a very analytical way can sometimes be difficult. And when COVID hit, we were all distant and separated, and I wanted a way to teach this remote class and bring an aspect of connection with the students to each other, to the community, and that's kind of where the idea of these kits were born from.
We, the students, created these kits as part of our grade and for the academic civic engagement portion of the class. And people can check out these kits and use them to teach science to kids. Essentially, they're especially useful right now during the pandemic with so much learning going remote and science education getting harder because of that.
It definitely was very challenging in a lot of ways, just because it was like, okay, like we're studying really hard course material, that community that we were all really used to that comes with this department, we weren't able to access anymore. I felt like I was able to connect a lot more with everybody just because we were working on something that was really fun, and we were all working towards a common goal of like, oh, we're gonna help these kids, discover why we love physics.
We've made 5 different kinds of kits. Each one has 2 to 3 experiments, and we have enough that we can give around 150 to 200 kits out to the public. What I really like about a lot of these kits are they're stuff that you can find around your house. So even if you don't have the kit, you can come to the website and you can look at the instructions and you can gather all the materials.
Our project was about music and sound waves, and we were really focused on helping kids visualize and really physically understand what sound is. We used Allen wrenches actually, so if you hit an Allen wrench with another metal object, it produces a tone, and different sized Allen wrenches produce higher or lower tones, and we were able to combine those and talk about the properties of the wrench and how it created these sounds to help kids learn about sound waves.
Coming up with ideas for experiments for this project was in of itself not a super difficult thing to come up with, but correlating that to common household objects was initially a bit difficult. We're like, what will everybody have? What's something that, people are guaranteed to have? And so we kind of went around asking different people oh, do you have this at home? Would you think this is easy access? And so if the answer was no, we're like, okay, we got to brainstorm something else.
We focused a bit more on the relativity side than the waves and oscillations, and put together a gravity well kit. I remember in high school, one of the things that got me into physics was seeing this big elastic sheet and putting the different orbits of the planets. And so we took that experience and said, hey, how can we make this easily distributable?
So having an ACE component in this project is really key. Sometimes physics and science can feel like a cold discipline where you're not really engaging with the public, but there's so many chances to engage with the public in career-wise with physics and science that it's not a sterile environment.
I've always found that I understand something more when I explain it to someone. And being able to take these complicated topics and saying, oh, here's how to explain it to an elementary schooler, a middle schooler, a parent who's supervising this. Taking those different steps of such an expansive theory allowed me to have a more concrete understanding of the topic and assist the community at the same time.